So last time we were talking about definition of limit of a function informally, that is by intuitive definition, and then the other one by formal or precise definition. Okay. I couldn't remember exactly where we ended, but let us have a recap of what we had, a quick glance of what we talked about last time. So for definition of limit of a function by intuitive approach, we have the following. If the values of f of x can be made as close as we like to the number L by taking the values of x sufficiently close to a, but a not necessarily in the domain of the function, okay? Or x is not necessarily equal to a. Then we say that the limit of f of x as x approaches a is L, and it is written as limit of f of x as x approaches a is equal to L. The limit of the form given in this informal definition is called a two-sided limit. For limit of f of x as x approaches a to exist and be equal to L, both the limits of f of x from the left and right directions of a as x approaches a must exist and are or be equal to L. Okay, guys? So these limits of f of x from the left and right of a are called one-sided limits. So if you have this notation, lim of f of x as x approaches a equals L, it means two-sided limit. And if we have minus on top of a or plus on top of a, we have what we call one-sided limits, okay? So namely left hand and right hand limits. So let's talk about one-sided limits. So for left hand limit, all you have to do is to replace certain phrase in the definition of limit of a function, two-sided limit. So by this, no? So if the values of f of x can be made as close as we like to the number L by taking the values of x sufficiently close to a from the left of a, then we say that the left hand limit of f of x as x approaches a from the left is L, and we write lim of f of x as x approaches a with negative on top of a to mean coming from the left of a, the values of x. So, and that is equal to L. For the right hand limit, so all we have to do is to change the word left to what? To right, no? If the values of f of x can be made as close as we like to the number L by taking the values of x sufficiently close to a from the right, so meaning x is greater than a, then we say that the right hand limit of f of x as x approaches a from the right is L, and we write, so this time with superscript on top of a, okay? For the graph of f below, so let's consider this graph. So if you are asked of the limit of f of x as x approaches 0, so x approaches 0, traveling along this curve or along this line, so we get 4, no? Limit of f of x as x approaches 1 from the left, so 1 from the left. From the left, we have 3. From the right, we have 4, but we want only from the left. I mean, from the right, we have 5, no? But we want only from the left of 1. So that is equal to 3, okay? And then if you have a limit of f of x as x approaches 1 from the right. So I think I answered that already now. So we have from the right, so that is equal to 5. And then limit of f of x as x approaches 2, meaning both from the left and right, both from the left and right of 2. So traveling along the curve, we go to 2. From the right, we go to 2 also. So it means the limit of f of x as x approaches 2 from both left and right. So two-sided limit, and that is equal to 2. Okay? If you have questions, you just speak or raise your hand. Meron bang raise of hand dito sa Zoom? So what about limits at infinity? When do we say that we have limits at infinity? When you say limits at infinity, we have either limit of f of x as x approaches positive infinity, or limit of f of x as x approaches negative infinity. Meaning we replace a by positive infinity or negative infinity. So, and if we have these notations, we mean limits at infinity. And what do we mean by the first one and the second one? So let's take a look at this graph. So if you're asked of limit, for instance, of f of x as x approaches positive infinity, we have as x approaches positive infinity, meaning as x goes to the right without end or without bound. So what do you notice about this curve? This curve approaches the yellow line. So it seems not to exceed the yellow line. So that is the limiting position or the height, limiting height, which is equal to 3, that limiting height. So we say that as x approaches infinity, positive infinity, the value of f of x approaches. So the value approaches this yellow, which is equal to 3. So we say that as x approaches positive infinity, f of x approaches 3. Equivalently, we have limit of f of x as x approaches positive infinity is equal to 3. Okay? Now what about if x approaches to the right, to the left, I mean, to the left rather, no? So x goes to the left. As x goes to the left, so what is happening to the function values of f of x, no? So f of x values gets bigger and bigger without end, no? The values go up. So it means as x approaches negative infinity, that is going to the left direction without bound, f of x keeps growing. So equivalently, limit of f of x as x approaches negative infinity, that is equal to positive infinity. Of course, we don't mean that the limit exists now. So this means that the limit does not exist as x approaches negative infinity. But as x approaches positive infinity, there is a limit, no? And it is equal to 3. Okay? But a horizontal asymptote, that is an asymptote, can be intersected. And it so happens that it is really intersected here. But possible also not to be intersected. But in this case, it is intersected. Aside from being an asymptote, horizontal asymptote, it is intersected there at -2, 3. Okay? Let's take a look at another graph. If you are asked of limit of f of x as x approaches negative infinity, that is equal to, so going to the left, what do you think the limit? Guys?
0.
Anyone? What do you think?
0 po.
0 po.
So going to the x-axis, no? So it means approaching the x-axis y equals 0. So f of x approaches 0. Okay? What about limit of f of x as x approaches 4 from the left?
3 po.
As x approaches 4 from the left, where does the function
Positive
value
infinity.
Positive infinity pala po.
Positive infinity
positive
po.
infinity? What about as x approaches positive 4?
3.
So So going to be 3. What about limit of f of x as x approaches positive infinity as
Negative
x keeps
infinity.
on
Infinity po.
going to the right? It
Negative
goes
infinity po.
downward, no? The function values go downward. So it means past negative infinity. Okay? Now we had this already, no? So this was what we graphed given the following properties. So yeah, let's just check that if these properties are really satisfied because we had this already last time. Limit of f of x as x approaches negative 5 from the right, negative infinity. Going to negative 5 from the right, okay, negative infinity. Limit of f of x equals 2 as x approaches negative 3. So this is negative 3 from the right, from the left, okay, 2. F of negative 1 is equal to 5. F of negative 1 is 5, okay. And the limit of f of x as x approaches negative 1 is also 5. So, okay. Defined, and of course, the limit exists also. Limit of f of x equals negative 1. So, let's see if it is satisfied as x approaches 1 from the left. From the left, so it is negative 1. No? F of 1 equals 2. So f of 1, 1, when x is 1, we have 2. Okay. And then limit of f of x as x approaches 1 from the right is also 2. From the right, 2. Okay. So f of 4 is equal to limit of f of x as x approaches 4, and that is equal to negative 3. So let's take first the point, 4, negative 3. So we have 4, negative 3. Okay. Limit of f of x as x approaches 4, negative 3 also. From the left, from the right, negative 3. Limit of f of x as x approaches 6 is equal to 1. Okay. From the left, from the right. So it is 1. Okay. Correct. F of 6 is equal to 0. So there is an isolated point here. So along the x-axis, 6, 0. Limit of f of x as x approaches 7 from the left, positive infinity. So it keeps on increasing as x approaches 6 from the left. As x approaches 7 rather from the left. Okay. So that is the possible graph of f. But it doesn't mean that is exactly. You can have other shape as long as those properties are satisfied. Now, for the precise definition of limit of a function, so we are going to consider the definition of limit of a function intuitively. So again, the intuitive definition of limit of a function is inadequate for some purposes because such phrases x is close to a and f of x gets closer and closer to L are vague or imprecise, no? So we're trying to extract from this intuitive definition the mathematical equivalence of phrases like x is close to a, f of x gets closer and closer to L. How do we express them mathematically? Okay. So we recall that the limit of f of x, if it exists, is a unique number L being approached by the values of f of x as x approaches a, or as x assumes values of x arbitrarily close to a, but not equal to a. So this notation, limit of f of x as x approaches a equals L, means the following. So we are now trying to extract from this intuitive definition the mathematical equivalence of these phrases. No? So we can make the values of f of x as close as we like to the number L. What do we mean by that? And also, by taking the x sufficiently close to a but not equal to a. What do we mean by that phrase? So let's start with the values of f of x as close as we like to the number L. So when f of x gets closer and closer to the number L, so we are talking of what? We're talking of distance. Okay? So meaning we can make the distance between f of x and L arbitrarily small. When you say arbitrary, you can move the value until it is what? Become small and small, no? Yeah. By what? By taking x sufficiently close to a but not equal to a. What does it mean? By taking the distance. So again, if you want your x to be close to a, so the distance is what? Between x and a getting sufficiently small, but not equal to 0 because x is not what? Not equal to a. So x minus a cannot be 0. Okay? And since it is distance, it is positive. And what do we mean by distance between f of x and L arbitrarily small? We can make the distance arbitrarily small. What do we mean by that? We can make the absolute value of f of x minus L arbitrarily small. Okay, guys? Remember, when you talk of distance, in terms of mathematical form, it means we're getting what? The absolute value of the difference between f of x and L. Okay, guys? Do you have any question? Do not chat in the box because I don't see your chats in the chat box. You just speak if you have questions. Okay, guys? So we're now close to the precise definition of a function, limit of a function. So imagine from values of f of x as close as we like to the number L, we're now on absolute value of f of x minus L arbitrarily small. And what do we mean by taking the distance between x and a sufficiently small, but not 0? So it means also the absolute value of x minus a sufficiently small, but x not equal to a. Okay, guys? So how to remove sufficiently small and make it mathematical really, and also how to make the absolute value of f of x minus L arbitrarily small, how to remove that word as arbitrarily small. So we mean we can assign a positive number, say epsilon, however small, so that this difference, take the absolute value, is less than that. Okay? So by finding corresponding positive number, delta, for which x minus a, take the absolute value, is less than that delta, and x not equal to a. So further, it means what? For any epsilon that is positive, we can find what? We can find a delta greater than 0 such that if this absolute value of x minus a is less than delta but not equal to a, it means it is between 0 and delta, that absolute value. Then f of x minus L, take the absolute value, is less than epsilon. Okay, guys? Did you get that, guys? Guys?
Yes, po, sir.
Let me check the chat box. You are just writing your attendance. Okay. So from these abstractions from intuitive to mathematical form, we can now define limit of a function precisely. So this is now how we define it. So definition of limit of a function, formal or precise definition. Let f be a function defined on some open interval containing a, meaning f of x is defined at every number in the interval containing a, except possibly at a itself, and L be a real number. Then the limit of f of x as x approaches a is L, written as this notation if it is true that Given any epsilon greater than 0, however small, we can find a delta that is positive such that this proposition is true, this conditional propositional statement. If the absolute value of x minus a is greater than 0 but less than delta, then the absolute value of f of x minus L is less than epsilon. Okay, guys? So that is now the formal definition of limit of a function. From intuitive, we now came up with what? With this definition. Final question, guys? If none, so we can continue. It's not moving anymore. I do not know why. Yan. Nag-stuck. So note the following are equivalent. Take note that when you say if the absolute value of f of x minus a is between 0 and delta, then the difference between f of x and L, take the absolute values less than epsilon. Yan. This is the same as what? In your logic, remember in your logic, Gen Math, this if then, you can write this using this one direction arrow, no? Instead of if then, you just have in between this hypothesis and conclusion, arrow to the right. You can have a thin arrow or thick arrow. Or you can change this arrow by the word whenever. So, but when you replace this by whenever, you have to interchange position of this, no? The hypothesis will be after the whenever, and f of x minus L, absolute value of that less than epsilon, is before whenever. Because whenever means actually if. If, ito ditong if, then ito yung conclusion. Clear, guys? Because you might see from other books or from YouTube different notations. So also, when you say absolute value of x minus a less than delta, so that is equivalent to x is between a minus delta and a plus delta. Okay, guys? So actually, that is equal to what? To absolute value of, x minus a is less than a plus less than delta, then that is greater than negative delta. Pag sinolve yung x, you will come up with this. And what does this mean? So this absolute value of f of x minus L is less than epsilon. That is equivalent to L minus epsilon is less than f of x, and that is less than L plus epsilon. Okay, guys? So they are just the same. Now, the formal definition of limit says that if any small interval L minus epsilon plus L minus epsilon, comma, L plus epsilon around L is given, then we can find an interval A minus delta, comma, A plus delta around A such that F maps all the points in the interval, open interval A minus delta, A plus delta, except possibly at A, into the interval L minus epsilon, L plus epsilon. So let's illustrate that. So through mapping, this is my, let's say, my values of x. So, and this is A. So from A, we move delta to the right, plus delta, then minus delta to the left. So we have this interval. So, and then on the f of x, or this the y values, so we have this corresponding interval. where it is centered at L. If I take a value of x here, so that is not A, but close to A. So for instance, this point, it is mapped to where? It is mapped to this point. It can be, that is just an example. If I take here, for instance, it can be mapped here. Or if I take here, it can be, as I get closer and closer to A, so the mapping will be a corresponding value that is closer and closer to L. And we say that L is what? Is the limiting value. Okay? As I mapped value here, close to A, as I mapped as in here, then I will be getting a corresponding value of f of x that is getting close and closer also to the pink point. Okay? So graphically, what does it mean, guys? So graphically, so let's draw graphically. So let's say I have this graph. This is my y. Okay. This is my x-axis, y-axis. And let's say this is my A here. This is my A. And this is my L here. This is L. So away from L, a distance of epsilon. So I have here a open interval. So this is L plus epsilon. This is L minus epsilon. And then corresponding here, so I have A minus delta, A plus delta. Okay, guys? So meaning this distance is delta. This distance is delta. This distance is epsilon. This is also epsilon. And if I'm going to consider point here, so is it aligned? But let's say generally it is a whole, meaning the function is generally not defined there. But no problem if it is defined. But we're not after x equals a, but the behavior of f of x as it gets closer and closer to a. Okay? So this is the graph of the function. Okay. So then I have this window. Let's have it yellow. So we have this window. Let's have it thinner. Okay. Yeah. So every time I pick a number here, yeah, it will not get out of this window, no? So and as I get closer and closer, I'll get closer and closer to L. Okay, guys? So if I get closer and closer here, I'll get closer and closer to L. So this mapping is equivalent to this graphically. So this is my function. So it's like a challenge, no? I will give you L as my limit. It's like that. I can always find a delta. Okay? So give me an L and I can give you a delta. It's like that, no? So give me an L and I can give you a delta that will satisfy the requirement of the formal definition. Is that clear, guys? Yeah. So let us use this definition in proving whether the limit of f of x as x approaches a is L. Actually, this is the hardest part in one of the hardest part in calculus, how to prove using delta epsilon limit of a function, no, of f of x as x approaches a is equal to L. It's easier to compute, but how to prove or verify that the limit is true mathematically using formal definition, that's what makes it difficult to do. Okay? So the challenging part in the precise definition of limit of a function, again, is when we wish to prove the limit statement. So let me write that. So the challenging part in the precise definition, I will have an activity regarding this, but group activity. If you're asked to prove, no? But I will not be asking you to prove in the quiz, just in the assignment, but by group, because it's not easy to do this thing. The challenging part in the precise definition of limit of a function is when we wish to prove or show so the limit statement limit of f of x as x approaches a is equal to L. Okay, guys? So showing that this limit as x approaches a is equal to L consists of two parts. So I'll be trying to show to you how to prove this limit statement. And let me see if I will able to give justice to this, because as I said, it's not easy to to talk about this, no? So it's like me, I can really do this, but to explain or to share this topic, I'm not really sure, because it's not all the time we discuss this, no? Especially in engineering, we don't discuss this thing, no? So for computer science, perhaps to BS math, of course, no? So they have this, okay, this topic. These are the two parts that you need to do when you are proving this limit statement. First, you have to find an appropriate delta. Find an appropriate delta. We call this preliminary analysis. It's like you are doing it backward, no? Actually, proving that this statement, where are you, statement, proving this is easier. What makes it difficult is to find that delta that will satisfy this, no? What is that delta, so that you will able to prove this conclusion, okay? So that's what it makes difficult. To prove easier, but to find the delta is the one that is a bit challenging. And then the second part that you're going to do, you have to show that the chosen delta works. You have to show that the chosen delta works. Okay? So basically, you're going to express delta in terms of epsilon. What is that delta in terms of epsilon? So that when you work on the hypothesis, you will come up with the conclusion, no? And we call this part the formal proof. Formal proof. Okay, guys? Guys, still alive, guys?
Yes po, sir.
Yes.
Okay, so let's do that. First, let me show to you these two parts, but by values for the meantime, so that you can understand what's going on when we actually use when we use the actual delta epsilon. But here we are going to put first values of delta and epsilon, and also for you to become familiar on how to write the statement that you're going to prove mathematically, no? So let's have example. Given that limit of three x minus 4 as x approaches, let's say, 3 is equal to 5. Find a number delta such that when I write later such that, I will just write ST, such that if the absolute value of x minus a, my a here is 3, is between 0 and delta, then the absolute value of f of x, my f of x is 3x minus 4, then minus L, f of x minus L, my L is 5. So the absolute value of this difference is less than epsilon. Okay, guys? But epsilon, I will put a specific value. Let's say my epsilon is let me have my epsilon as 0.01. I want it 0.01. Okay? So remember, epsilon is supposed to be positive. Actually, this number 0.01 is error tolerance, no? We call that error tolerance. And that error tolerance, you can have it less than that pa, if you want. You can start with 0.1 if you want, and then 0.01, 0.001. As you assign an error tolerance, you can always find a delta such that this will become true, no? Yan. So, solution. Nagahang. Hindi ba nagahang sa inyo? Guys? Guys? Naku, ayan na naman. Ang sakit niya.
Medyo lag lang po.
Nagbi-blink-blink na naman. Ang sakit na naman sa mata. So, solution, we have... Okay? So here, we are working on a given value of epsilon. Okay? So we're given epsilon is equal to what, guys? 0.01. Okay? And we want to find what? We want to find a delta such that, okay? So we want to find, so this is given. We want to find a delta such that, so it's blinking, such that this inequality, absolute value of x minus 3 is between 0 and delta. So if then this difference, what is my f of x? 3x minus 4, no? So, okay, guys? 3x minus 4. That is 3x minus 9 actually. Na. Am I correct, guys? 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 Am I correct? 3x minus 9, right?
Yes,
okay? So note that, hindi sa inyo nagbiblink sa akin eh. Nakakasakit ng mata. May problema na yata itong computer ko. Note that the absolute value of 3x minus 9, which is ito originally yon, I can write this as what? I can factor out 3 and then I get, ay sorry, yan, naghang na, x minus 3, kailangan magaling kayo sa inequality. Tsaka, yan, absolute value. And what is the absolute value of product? If I have absolute value of AB, that is equal to what, guys? Absolute value of A, absolute value of B. Am I correct, guys? So what is the absolute value of 3? That is 3. then absolute value of x minus 3. Okay? And this is supposed to be less than what? 0.01. Am I right? Yan. Remember, we're trying to find a delta that will satisfy this. So we are working backward. So let's begin with this conclusion and then try to find out that delta that will make this true. Okay? So what is now delta, guys? If I divide this by 3, this inequality, I get what, guys? So I get absolute value of x minus 3 less than what? So this is equivalent to this.
0
Less than
0.0033.
0.01 over.
0.01
Let's my
over 3.
calculator because I don't have solution to this. 0.0 in, I just made a problem. 0.01 divided by 3. Okay, guys?
0.003.
0 point dot dot dot. So in fractional form, it is 1 over 300. Am I correct, guys?
Yes po.
1 over 300. Well, let's just have it because it's not exact. So let us just have it this fraction. But this is small, no? Which is around what? 0.003. Am I correct, guys? Guys?
Yes.
Around this, no?
Yes po.
This is just an approximate. So what does it mean? From this result, a suitable choice of delta is this value, this 1 over 300. Remember, x, absolute value of x minus 3 is less than delta. So what is supposed to be our delta? So a suitable choice of delta is equal to what? 1 over 300. Okay, guys? So corresponding to this error tolerance, which is 0.01, so the delta is 1 over 300. Okay? So if you have another 0.001, you can find another delta. 0.00001, you can find another delta. So in other words, later when you ask to prove this, let's say, we are going to make use of delta and epsilon rather than having the actual error tolerance. To what? For the epsilon to be any. Okay? Because if it is true for 0.01, it must be true for what? 0.001. So this limit, no? And so on. So we will be using arbitrary delta and arbitrary epsilon. Okay? So let's see if this will work. No? Does this really the correct delta? Will this really work? Let's find out. Okay? So let's see. Let us see if it will work. Let's check. Let's check if delta, which is equal to what? What is that value? 1 over 300, no? Works. So to determine if it works, so all you have to do is what? Is to begin with this hypothesis. We know that ayaw tumigil mag-blink. The absolute value of x is minus 3 is between what? Between delta, no? Yan. And this implies that the absolute value of x minus 3 is, but what is, by the way, what is our delta? This is 0 less than absolute value of x minus 3. Nagpapatay hindi kasi kaya hindi ko mabasa. Less than 1 over 300. Yan. So this implies that if I multiply this by 3, I get what? I get yan, 3 times 1 over 300. Okay? So from here, remember, my goal is to derive this. So you have to find a way on how to come up with inside absolute value 3x minus 4 minus 5, meaning 3x minus 9. So that is equal to absolute value of 3 times x minus 3. And that is 3 over 300 is 1 over 100, right? And we know that this is 3x, inside is 3x minus 9, okay? And that is less than 0.01. That's it, guys. So this confirms that the right delta is 1 over 300 for that given error tolerance. Okay, guys? Is that clear, guys?
Yes, Pastor.
Actually, if 1 over 300 works, any number less than 1 over 300 could also be used, and it will work also. And you will have less than 0.01 also. Okay, guys? So let's have the actual proving, no? Using limit definition, that is Delta-Epsilon. Okay, so this is the problem. Prove using Delta-Epsilon definition of limit prove that number 1, limit of 2x plus 3 as x approaches negative 4 is equal to negative 5. Is this correct? Negative 8 plus 3, negative 5. So we want to verify that this limit is true, this limit statement, making use of Delta-Epsilon definition of limit. It's easy to compute, negative 8 plus 3, negative 5. But to prove, that is what makes it difficult, no? So, because later when we go to algebraic technique of finding limit, actually, since this is a polynomial, in particular linear function, so you can actually apply substitution technique to get -5. Okay? So, but to prove, that's not what makes it not easy, no? Let's begin. So, solution. You listen very careful, ha? When you prove, it's not like an ordinary solving type of problem. Your lines should be correct. So mathematically written, and you have to follow format, accepted format. So here, what is our A? You can do this mentally. It's all right not to write, but let me identify our A. Our A here is what, guys? What is our A in the problem? Guys, -4.
-5.
What
-4
about
po.
L?
-5 po.
-5. Remember, this is what we are trying to write, no? Itong statement na ito. We will be writing this. But you are going to replace, where is the definition? But you are going to replace by this, by the actual value. Okay? And the L. You have to come up with this. So, let epsilon greater than 0 be given. So that's the starting line. We want to find a delta such that the absolute value of x minus a, what is our a? -4. So it becomes x plus 4, right? Is between 0 and delta. Then, so if this is true, then f of x, take the absolute value of f of x, that is, what is our f of x? 2x plus 3 minus L minus -5, so it is now plus 5, is less than epsilon. Okay? So that's what we need to prove. Again, given that epsilon is greater than 0, so we need to find, we seek a value of delta such that this is true, this is statement. So first step is to find the delta, no? So we are going to do it backward. So we start here and then try to come up with the value of delta, meaning you try to put this in this form so that you will know what delta is. Because if you will able to put this in this form and you can get a delta that will satisfy this, means this is true, no? So otherwise, this is not a true statement. So find an appropriate delta. Find an appropriate delta. How to find an appropriate delta, guys? Note that, again, the absolute value of 2x, actually when simplified, ano to when simplified, guys? Ilat mo na lang dito, ha? The 2x plus what? Plus 8, right? Na? Guys, this part. Okay? Take note that 2x plus 8, that is 2x plus 3 plus 5, the actual. That is equal to, I can factor out 2 to get.
Did you have class bot this week or no? Di ba it's kuan may ABM Bazaar? May class iba ka mo? Or what?
Nag-uusap?
Oh. So may class ka mo? Oh.
What's going on? Paki-ano muna yung mic, Iho.
At least.
Iho.
Until what time din ba?
Ha?
This is equal to
Depende. Sometimes until
Iho,
4, tas sometimes mga 2.
Iho,
Kyle Tan.
Kyle, who's that?
Sir?
Could you please turn off first the mic?
Oh, sorry, sir.
Okay. So again, 2x plus 8, absolute value of that is equal to 2x times x plus 4 absolute value. And what is the absolute value of product? So product of absolute values. Okay, so absolute value of 2 is 2 times absolute value of x plus 4. And this is supposed to be less than epsilon. So what is now absolute value of x plus 4? And that is epsilon over 2. Okay, guys? So the appropriate perhaps delta is what? So choose delta, which is equal to epsilon over 2. Actually, any epsilon, delta that is less than or equal to epsilon over 2 can be considered also. Okay? So we can start with epsilon over 2, but any value of delta that's less than epsilon over 2 can be considered. Okay, guys? So again, or any that, but we choose epsilon over 2. So let's see if this epsilon will work. Okay? Guys? So let's find out if that will work. So we have show that, yan, nabuhay na uli. Namamatay eh. Show, sa inyo guys, hindi nawawala.
Hindi po.
Nagbiblink sa akin, parang ilaw na nagbiblink. Ano kayong problema ng laptop? Show that show that delta works. So we know that 0 is less than absolute value of x plus 4, and that is less than epsilon delta, no? Yan. So here we have absolute value of x plus 4 is less than, but what is our delta? Epsilon over 2. Okay? So let's multiply this by, because we need to come up with this, no? 2x plus 8. We need to multiply by 2. Let's multiply that by 2. So 2 times absolute value of x plus 4, and that is less than 2 times epsilon over 2. And this implies that 2 times x plus 4, take the absolute value, is less than epsilon. And this is 2x plus 8, which is what we want, less than epsilon. Okay, guys? So that's it. Since this delta, which is equal to epsilon over 2 works, meaning we have shown that for delta that is equal to epsilon over 2, we have shown that this absolute value of 2x plus 3 plus 5, which is equivalent to 2x plus 8, is less than epsilon. Okay? Guys, so again, we have shown that, limit of f of x that is to, what's the limit? I'm sorry. We have shown that two x to what? The original 2x plus 3. 2x plus 3 plus 5 is less than epsilon if ang hirap magsulat pag patay sindi. Is less than, is it x plus 3 guys or x, what is that? X plus 4. X plus 4, that absolute value is between 0 and delta. Okay guys? Therefore, limit of 2x plus 3 as x approaches negative 4 is equal to negative 5. Okay, so that's it. That's how to show or how to prove using delta-epsilon. O, di ba hindi siya exciting? Okay, so let's have another one. Number 2. Limit as x approaches negative 3 of x squared minus 9 all over x plus 3 is equal to negative 6. What about this? So again here, what is our A? Negative 3. What is our L? Negative 6. So let epsilon greater than 0 be given. That's how we begin. We want a delta such that if the 0 is less than absolute value of x minus a, that is x plus 3, because x minus a is negative 3. So between 0 and delta, then this difference, take the absolute value, x squared minus 9 all over x plus 3 minus negative 6, so plus 6, is less than epsilon. Okay? So let's have now the first step. So find an appropriate delta. Find an appropriate delta. Okay? So note that this one, actually we can simplify this, no? Let's simplify this, no? Let me have it here. This one, I will put asterisk to mean that's what I'm trying to simplify. So I can cancel x plus 3, no? What is left? X minus 3. Am I right, guys? And then I can cancel x plus 3 because remember, x is not negative 3. X is just approaching negative 3. So I can cancel that. So plus 6. So and that is equal to absolute value of x plus 3. Okay, guys? So this is yan, same with this. So that later, I'm not going to make use of this. So I can now begin with what? With x plus 3 rather than this complicated form. So x plus 3, and that is supposed to be less than epsilon. So that's it. So what is the appropriate delta, guys? So choose delta equals epsilon. Of course, any delta that is less than epsilon can be chosen also. Okay, guys? Second step, let's check if this will work. So show that, this is easy, no? Show that delta works. Okay, guys? Hi, guys, did you get that? Why I get immediately epsilon? This is what I am supposed to use as a backward solution. But I already simplified this into absolute value of x plus 3. And it so happens that I got this already, this part. So it means delta is epsilon. Okay? Guys, wala nang kausap. So we now have 0 is less than absolute value of x plus 3. So this is it. And that is less than epsilon. Delta rather. And that is absolute value of x plus 3. But what is this? Epsilon. Oh, that's it. Remember, x plus 3 is what? Is absolute value of that is equal to this. So this is what we want. And that is less than epsilon because delta is epsilon. Or since we have verified that this is true, so hence, we say that limit of what? Of x squared minus 9 all over x plus 3 as x approaches negative 3 is equal to negative 6. A question, guys. Mr. Secretary.
None po so
None
far
po.
from me.
No question.